Salutations. The video you have just seen is of a bowling ball being released, thrown out onto a bowling lane, as described in the picture here. Now, you may be wondering to yourself, what is happening to that ball as it goes through the air and when it hits the bowling lane? Well, there are a few basic terms that you should be familiar with before I can explain the basic kinematics of this. They are position, velocity, acceleration, vectors, and the components of a vector. A vector is an arrow from one point to another, essentially describing the motion going to that point. For example, a position vector will describe where the position of something is relative to a coordinate system. So if you have x and y here, positive y and positive x, let's say you have a point P. P can be given as 5, 5. 5, 5. That's just a point. You can have a vector going from the origin to P. Now that vector would look very similar to P, except that you can name it with the letters I and J for x and y respectively, or you can use the same notation as P, but with bent brackets rather than curved ones. So the vector, now let's call this point O for origin. The vector OP is bent bracket 5, comma 5 bent bracket, which can also be written as 5 I hat plus 5 J hat. The hats on the I and J indicate that this is a vector, not just a line or a point. Now about these vectors here, position, acceleration, and velocity. Position represents where something is relative to a coordinate system. For example, this bowling ball, at that moment where it's drawn, is a little bit in the positive y and a little bit in the positive x directions. Initially, based off this line here, the bowling ball was a little bit in the positive y direction and at 0 in the x direction. Velocity vector is the change in the position vector over time. For those of you who've taken calculus before, you have an idea of what I'm talking about. It's a derivative. That arrow represents that it's a vector, that's what the arrow means. Is the change in position over time. So whatever the position is, the velocity represents how that changes over time. For example, if the ball was thrown up in the air and then came down onto the lane, position would be given by something like that. Velocity would be the derivative of that, which would look something like this. Oops. As the derivative of a quadratic will always be linear. Now acceleration has a very similar relationship to velocity. In fact, it's the same. Acceleration is equal to the change in velocity over time. Which that, in this example, if the velocity is constantly decreasing, the acceleration must be constant, and it must be negative since the velocity is decreasing. So that would look something like that. Back to this bowling ball. There's a bowler right here, and the bowling ball going through the air down onto the lane. Why is it that the bowling ball just doesn't keep going straight across? It does have initial velocity often noted as V naught or VI for initial, coming straight out in just the x direction. Well, that's because of this acceleration due to gravity. As the ball moves in the x direction, it is keeping a constant velocity in the x direction because there's no forces in the x direction acting on it. However, there is acceleration due to gravity, since this is on Earth, hopefully. Because of the acceleration due to gravity, which near the surface of the Earth is 9.81 meters per second squared, the ball is pulled down toward the surface of the Earth. So there's a little bit about two-dimensional motion. Now, three-dimensional motion is very similar, except that there's a third dimension. So instead of just having x and y, you'd have this z as well. Velocity would be given by the velocity in the x direction, y direction, and in the z direction. Now that you've learned a little bit about these vectors and how they work with each other, you've heard me say component and in the x direction a few times. That's referring to the velocity is overall velocity, acceleration, overall acceleration. Both velocity and acceleration have components, which is the velocity specifically in the x direction and specifically in the y direction. To find that, we can go back to geometry and do some trig with this triangle here. If we know the angle to the x-axis, and we know what the initial acceleration, in this case, that A vector is acceleration, then we can figure out the acceleration in the y direction and acceleration in the x direction. Y, being opposite of theta, would be equal to A sine of theta. X being adjacent would be equal to A cosine theta. And if you know both of these, but not the overall acceleration, you can use Pythagorean theorem. Ax squared plus ay squared will equal a squared.